Good morning, ma'am. Good evening, ma'am.
Good evening,
Ma'am,
ma'am. Ma'am, your voice is very low.
are you away from the mic? And your voice is too low. You are quite a distance.
What about now?
Perfect, ma'am.
Good, ma'am.
Now it is fine?
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay. All right. We'll start with today we have week 5 solve with us. But we will not do our peer deck slides. Okay. I'll just present you the questions and we'll solve the problems.
Okay, ma'am.
Okay, ma'am.
Yeah.
Ma'am, week 5 is quite tough.
Week 5 is tough.
Yes, ma'am,
Which
quite
which
tough.
which part of week 5 you're finding tough?
Continuous random variable
Continuous random variable.
and expectation also.
Expectation also. Okay.
Ma'am, conti- uh, joint distribution of coin, continuous and discrete. That one.
Are you able to see my screen? Can someone confirm?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am. Yes, ma'am.
Okay. So we'll start with our first theorem. Um, so all of you would have seen this theorem while studying week 5, right? And what is this theorem called?
Monotonic differentiable function.
Ma'am, monotone.
Monotonic differentiable function, right? So it says, suppose you have continuous random variable x whose PDF is f of x. If you take any monotonic function g of x over the support of x, over the support of x, right? And if its derivative of gx is g dash x, then how do you define the PDF of? How can you define the PDF of y? So this PDF of y, which is given as f5y, it is nothing but fx of g inverse of y. Okay, fx of g inverse of y divided by mod over g dash of g inverse of y, right? So this is the monotonic differentiable function. Now, you would have seen many different problems based on that. Even in the lecture, even in the your activity question, graded question tutorials, you would have seen plenty of problems on this topic, right?
Yes, ma'am.
Okay. So let's proceed with our first question. So using this theorem, we'll see our first question. Okay. So what does this question say? Suppose you have a random variable x, which is continuous, and it has the PDF fx equal 3x square for x lying between 0 to 1, 0 otherwise. Now let's define another random variable y, which is nothing but x of cube. So can you give the PDF of random variable y? So let's take some time and solve this.
Ma'am, you're not audible.
No, I'm not speaking. I muted myself. Uh, the screen is visible to you.
Yes,
Yes,
ma'am.
ma'am.
You are able to see the question.
Yes, ma'am.
Okay. So no, I wanted you to solve it, try it for some time, and then I mean it's the same way the way we used to do solve with this. It's not a pure deck slide. So just take some time and solve that problem.
Okay, ma'am.
Yeah.
Do
Ma'am,
we put
screen is not
answers in chat box?
Sorry.
Hello, ma'am.
Yes, tell me.
Ma'am, screen is not visible.
My screen is not visible. Okay, wait.
Ma'am, do we have to put answers in chat box? Or
No, I mean you can raise your hand maybe after 2-3 minutes. I mean I will. You can raise your hand and then we can discuss. Okay.
once we complete? Uh, Okay.
Ma'am, is there any option for this question?
No, there is no option. There is no option for this question. Did anyone did anyone solve this question?
I'm solving.
Yeah. So what is the first step that you have to do? So if you look at yeah if you look at this theorem, first of all you should identify what is your gx. So what is gx here?
Ma'am, x cube.
Gx is x cube, right?
Yes,
Now
ma'am.
next is we also see that in the formula you have g inverse of y and also g dash. So I should know what is g inverse of y and also what is g dash, right?
Yes, ma'am.
So what is g dash?
Ma'am, g dash is 3x square.
3x square, right? And
Yes,
what
ma'am.
is g inverse of y?
Ma'am, y power 1 by 3.
Y to the power 1 by 3. So we know what is my gx, we know what is my g dash of x, and we also know what is my g inverse of y. Now we just have to put everything in the function in this fy of y, and we should get our answer.
Yes, ma'am.
And also one more thing to be very careful here. So your second line of the theorem says let gx be monotonic for support of x. So you should always check whether your gx is monotonic or not, right? So here gx is gx is x cube, and what is my support of x? 0 to 1. 0 to 1. So is my gx monotonic on support of x?
Yes, ma'am.
Yes, right? And it
Yes,
is,
ma'am.
so is it increasing or decreasing?
Ma'am, increasing.
It is an increasing function, right? So in the support of 0 to 1, my gx is increasing. So it is monotonic. I know what is my g inverse of y. I know what is my gx. So now I just have to go and plug in the values. So my y is x cube, that is gx, right? And we found g inverse of y to be y to the power 1 by 3, correct? So g inverse of y is nothing but y to the power 1 by 3. And my gx is x cube, which is, so that implies my g dash of x will be 3x square, right? So here in the formula, we have fy of y to be fx of g inverse of y divided by g dash of g inverse of y whole mod, right? So we know what is g dash. We know what is g inverse of y. So now we have to compose these two functions and we have to find what is g dash of g inverse of y. So see here in the second last line, we are saying this g dash of g inverse y. Okay. So what is my g inverse y? My g inverse y is y to the power 1 by 3. So this becomes g dash of y to the power 1 by 3, right? And what is my g dash of x? G dash of x is 3x square. So g dash of y to the power 1 by 3 should be, so you will take 3 times whatever input you are giving. So in the previous case, my input was x, but here my input is 5 to the power 1 by 3. So whatever input you are taking, the output is coming out to be 3x squared. So here also, since in the input we have y to the power 1 by 3, so in the output you should get 3x square, right? So 3y to the power 1 by 3 whole square. So that becomes 3 into y to the power 2 by 3, correct? And if you take the mod of it, since if you look at the denominator, we are interested in the mod of g dash of g inverse of y. So if you look at the mod of it, it is nothing but it stays 3 to the power 3 into y to the power 2 by 3. Okay, this is fine. Then
Yes,
next,
ma'am.
we have to look at what is the effects of g inverse of y, right? So again, we'll substitute g inverse of y over here in the fx thing. Right? So g inverse of y is y to the power 1 by 3. And what is my fx? So look
Ma'am,
here. So my
3x2.
fx is 3x squared, right? So if my fx is 3x squared, then my fx of g inverse of y would be what? Same,
Ma'am, 3y 2 by 3y power 2 by 3.
same. It stays the same, right? Whatever we got as in denominator.
Yes, ma'am.
So it still becomes 3 times y to the power 2 by 3. And if you divide it, you get 1. So what is the CDF, sorry, PDF of y that you get? It is nothing but y. So you found y, but what about the range of values that y take, or what is the support of y here? That also we need to find, right? So look at x. X was 3x square. X lies between 0 to 1. You defined y to be x cube. So where do you think y should lie?
Ma'am, 0 to 1.
0 to 1, right? Is this clear to everyone?
Yes, ma'am.
Ma'am, I did not understand how you got one.
Okay, maybe I will share, I will edit the slides. Just give me a minute. Okay. Let's see here. So our question was, okay. Our question was fx of x equal to 3x square, right? This was the original PDF for
Yes, ma'am.
x lying between 0 to 1 and 0 otherwise. My y was defined to be x cube, and we had to find fy of y. This is what we had to find. Now, what we said is that my gx is nothing but x cube. Okay, so
Yes,
that
ma'am.
implies my let me first write the formula. So in the side, I will write the formula. So my fy of y should be fx of g inverse of y divided by mod of g dash of g inverse of y. Okay, this is my formula. So I need my gx, I need my g dash of x. So g dash of x is 3x square, and my g inverse of y is y to the power 1 by 3. Okay, hope this till here it is clear. Now what we wanted is, now we want to calculate my numerator and denominator also. So my numerator is fx of g inverse of y. Okay, so what is fx of x? It is 3x square. So my g inverse y, which was y to the power 1 by 3, and we knew that my fx of x is 3x square.
Yeah,
So
excuse me, ma'am.
yes,
Excuse me, ma'am.
tell me
Ma'am, I didn't get this line.
which line.
Y inverse G inverse is equal to
This you didn't
y
get.
to the power cube. Yeah,
Okay,
yeah.
so what you have to do is, see here. So your gx, right? So gx is nothing but y. Okay, so y is equal to x cube. So you have to write your x in terms of y, basically. So x would be what? Y to the power 1 by 3. And this is nothing but, this is what we are saying. It is the inverse of g. It's fine.
Yes, ma'am.
So your
Ma'am,
gx,
how G inverse came, ma'am? G inverse,
inverse you would
how
have
G
studied
inverse
in
came?
maths class, no? Maths one, you would have studied this.
I studied.
You studied, right? So inverse means what? Inverse means, like, if you multiply in general, if you multiply this, let's say x, with some number, it should give you 1. So what that number would be? I mean, this is how you look at inverse, no? I mean, if you, let's say you have some number, let's take some number. Let's say I have 3. So what number I should multiply 3 to such that it should give me 1?
1 by 3.
I should multiply it by 1 by 3, right?
Yeah,
Similarly,
yes, ma'am. Yes.
if I have x, what number I multiply x with so that it gives me 1? So I should multiply it by 1 by x, right?
Yes, ma'am.
So here we have gx to be x cube. So what number I multiply my x cube as so that it gives me 1? That should be 1 by x cube.
Yes.
Um, okay, wait.
इसमें y is equal to gx. Here
Mm,
it is showing that
mm,
x
wait,
is equal to gx.
see. Mm, okay. You have gx, right? So your gx is x cube. Okay. And we are saying take this gx to be y. Suppose this the gx is y. So now we have y to be x cube. Okay. And now you
Oh,
should
okay, ma'am. Now got it. Yeah.
now
Gx
you
is
should
immediate.
gx is y. Okay.
Yes, ma'am.
Gx is y. So now what you should try to do is you should try to write your x in terms of y. So if you write your x in terms of y, what will you get? It would be y to the power 1 by 3. X would be y to the power 1 by 3.
Yes. Yes, ma'am.
Yes. And this is nothing but, so x is nothing but g inverse of y, which is y to the power 1 by 3. Why is x equal g inverse y? See from here. So you have y to be gx. So if you take g on the other side, so you'll have g inverse of y and stays the x. Okay. So that's how your
Okay, ma'am.
g inverse of y is coming to y to the power 1 by 3. Now coming to f of x, we have fx of y to the power 1 by 3, right? So look here, you have in the question, fx was defined as 3x square. Okay, fx was defined as 3x square. Now, similarly, now this is your x to say. This is nothing but your x, small x. So you should
Yes,
do
ma'am.
this as 3 times x square. So what is x here? It is y to the power 1 by 3. And you have to take the
Yes, ma'am.
square on this. So this should be 3 times y to the power 2 by 3.
2 upon 3.
Okay. So we found fx of g inverse y. Now we want my g dash of g inverse of y. So that would be what? So that would be g dash of, again, g inverse of y is y to the power 1 by 3. So g dash of x, we saw it is 3x square. So again, this is my x, right? This is my x. So g dash of x is 3 times x square. So this square, which is 3 times y to the power 2 by 3. Right? Now let's find fy of y. So from the formula, we have fy of y to be fx of g inverse of y divided by mod of g dash of g inverse of y. Right? So in the numerator, we got it to be 3 times y to the power 2 by 3. Denominator, it is again 3 into y to the power 2 by 3. So it comes out to be 1. So fy of y is nothing but 1. But then what is the range of y, right? So we saw that my x, so my x was between 0 to 1, right? And fx of x was 3 times x square. So it would go something like this, right? You will have some curve. And what is y? Y is x cube, or maybe let's not do this. So you can see like this. So x lies between 0 to 1, right? So what is y? Y is x cube. So if you put x to be 0, it is still 0, x cube will be 0. And if you put x to be 1, this again x cube will be 1. So the minimum value that your y can take will be 0 and the maximum value that your y can take is 1, right? So what we write it as? So my PDF of y is nothing but 1 for x lying between 0 to 1, 0 otherwise. It means that, what does it mean? It means that my y is uniform in 0 comma 1. Okay.
Ma'am,
This question is clear.
why do we take absolute?
Why do we take absolute?
Yeah.
Um, because see, you're finding fi of y, no? It cannot be negative, right?
What happens if it is negative?
Fi of y is density. There
Okay,
is a
okay,
separate proof
okay.
also for there is a separate proof for this formula. If you are interested, you can just check it once.
Yeah, yeah. It's explained in the open session also.
No, formula derivative is proof.
Yeah, Subhajit's approved it in an open session.
Shubhajit,
I don't remember his name actually.
Max,
It's in
is
the
it
open session
Max?
of.
Okay, the previous
I don't
Max
I
know who
session.
is
think
he,
Prasant
but
sir. Prasant.
no, not Prasan sir. I don't.
Okay,
It's in
you know the
the.
proof of this theorem.
Yeah, yeah, I know.
Okay, that's good. Yeah.
Okay.
Okay. Yeah.
So the
Let's
probability cannot be negative, that is why we take.
density cannot
Yeah.
be negative, right? It is
Mm.
always positive. But you
Oh,
have a
PDF.
mathematical proof also for this formula. I mean, for this theorem.
Yeah.
Yeah. Okay. Let's go to the next problem. So next, what we have is next we are just looking at one theorem. So if you have any continuous random variable whose density is fx of x, and if we define a function g from R to R, then expected value of g of x, which we denoted as expected value of g of x, will be given by integral of minus infinity to infinity g of x times fx of x dx. Okay, whenever this integral exists. So this is very similar to what we had seen in the discrete case. So if we have a function of, if let's say we have, if you're talking from the discrete case, so let's say if we have a function x, if we have random variable x which is discrete, and if we define a function of this random variable, say gx, and if we are interested in finding the PMF of that gx, then what did we do? We just did sum over this g of x times PMF of x, right? So same thing we are doing for the continuous case. So now we have a random variable x which is continuous. We have a PDF for this random variable. And now if we have to, if we are defining a function g of x, if we define a function of x, so finding the expected value of g of x is nothing but integral. So since now we're talking about the PDF, so that the integral, the summation gets converted to the integral, and we define this integral over this whole range. So now my x varies from minus infinity to infinity. So g of x times fx of x dx. This is how you calculate the expected value of g of x. So on the same line, we have one question here. The question says, I think the theory here does not matter much. Basically here you have a random variable x whose PDF is given to you as 1 upon 20, where x lies between 0 to 20. Then you have to find out what should be the expected value of x cube. So let's take some time, maybe 2-3 minutes, and try to do it yourself, and then we'll discuss the problem. Okay, did anyone solve it?
Done, ma'am.
Done. What is the answer?
Ma'am, 2000.
2000. Anybody else?
Yes, yes, ma'am. 2000, ma'am.
2000 only. Okay. So here you have the PDF given to you, which is 1 upon 20. So can someone tell me, like, does this x follow some distribution? I mean, do you know any uh, continuous distribution which it resembles, this PDF function?
Ma'am, uniform continuous distribution.
Uniform between?
0 to 20.
0 to 20.
Uniform between 0 to 20. Okay. So here, what is your gx? Gx is again x cube.
Yes, ma'am.
And now you have to find the expected value of y. So expected value of x cube. So that would be integral of x cube times fx of x dx, right?
Yes, ma'am.
And what is your lower limit? 0.
Ma'am, 0.
0.
And upper limit would be 20. So that is what we have done here. So x cube times fx of dx, which is 1 upon 20 dx. And the range, the upper and the lower limit varies as 0 to 20. And you solve it and you should get 2000 as the answer. Anybody has any doubt in this question?
No, ma'am.
No, ma'am.
Okay. All right. Let's move to the next one. Again, it is a continuous random variable and its PDF is given to you. And what you have to do is to find the to find the value of 2 times expected value of x. Here integration would be a little difficult, but not very difficult. I mean, is just slightly difficult from the first one. So just try to do this question also.
Hello, ma'am.
What is g of x, ma'am?
G of x is okay. G of x is same as what we had defined above. Oh no, sorry. Yeah, g of x is g of x is just x over here. You don't have any y.
Ma'am.
Yes, tell me.
So answer I have to give in chat.
Answer you can give in chat or you can raise your hand and tell me. I mean, I will ask the answer in some time. So
Okay.
you can solve for this question. So did anyone solve this question?
Yes, ma'am.
What is the answer?
2.
2.
Ma'am, 1.402.
Yes, ma'am. 1.4022.
1.402. Okay. So here what you have to do, you have to find expected value of x and you have to multiply it by 2. Okay. So expected value of x, you will find it as integral of x times fx of x dx, where x lies between 0 to 1. You just do the integration, and whatever the final result comes, you multiply it by 2. So if we do this, we got expected value of x to be 0.701, and if you multiply it by 2, I got the answer as 1.402. So 1.402 is the right answer. Yes. So this is quite simple, right? I mean, not very difficult. You have a
Ma'am,
PDF.
here
Yes, ma'am.
x is not given. Why are you taking it gx equal to x?
Gx is not given.
Yes,
See,
ma'am.
expected value of x means what? It is x times fx of x, right? If I would have written in place of x gx, then it would be expected value of g of x. So then you would have done g of x times fx of x. So here my g of x is nothing but x itself.
Okay.
Yeah.
Thank you, ma'am.
So any doubt in this question?
No, ma'am.
No, ma'am.
Okay. Let's go to
Ma'am,
the
can you
next
show
one.
the solution once, please?
Yeah. Hmm. Okay.
Ma'am, in third line,
Hmm.
how you get to 15x raised to power 4?
Yeah, ma'am, can you explain that? I'm
15x
getting
to the power
one.
4.
And
See,
also 14x raised to power 3.
because you are
The third
multiplying by
line, ma'am.
x, you are multiplying by x. So what is the integration of x cube? It will be x to the power 4, no?
It's for 4.
So if you take this 1 by 12 outside, so this in the fourth line, 1 by 12 we take outside. So inside you will have 15x cube plus 14x square. Now if you integrate this 15x cube plus 14x square, you should get 15 times x to the power 4 by 4 plus 14
Ma'am,
times x cube by 3.
why we multiply by x?
Because we are finding expectation, no? So see, if we have any random variable x, okay, and we let's say this PMF, let's say this is a discrete random variable, and PMF is given as px of x, okay. And if I ask you what is e of x, what do you do to find this? You will do e of x is equal to sum over x times px of x over x belong to the range of x, right? Similarly, when I'm talking about the discrete continuous case, I have my random variable x, which is now continuous, and I'm saying my PDF is f of x of x. So if I ask you what is expected value of x, so what do we do? So expected value of x is going to be, so in our discrete case, what was summation? In the continuous world, it is going to convert to integral. So this also you would have seen in your maths class, right? So now in place of summation, we will integrate this. So we'll integrate over the support of x, let's say it is sigma, and it would be integral of x times fx of x dx, right? So in our example, let's say whatever fx was, I'm not going to write that. So it asks you to find 2 times expected value of x. So this would be 2 times integral of x times fx of x dx, and x varied from minus infinity to infinity, right? So even in our question, I mean, you have to multiply by, I mean, in our question, it was asked you to find expected value of x. So this is how we find the expectation.
And ma'am, when some function is given, like in the previous question, it was gx, so we'll just directly multiply that function with fx
Yeah.
into dx.
So if we had some function g of x, then this would be just integral of g of x times fx of x dx, right?
Yes, ma'am, clear.
Yeah.
Yes, ma'am.
Okay. All right. So in this question, we have again the same, I think it's the same PDF that is given to you. Now we have defined y to be 2 of x. So just find the variance of y. It might take some time because you have to find the variance. Just try it for some time.
Can you please show the question, ma'am? Yeah.
So, anyone solve the question?
Then ma'am 0.20.
What is the answer?
0.20 ma'am.
0.20. Okay, let me see. Yeah, 0.20 is the right answer. So this is clear to everyone, like how to do it. Like, what is the formula to find the variance of y?
Ma'am, expectation of x square minus expectation of x whole square.
Yeah, we know this relationship between the expectation and variance. So that is variance of x is equal to expectation of x square minus expectation of x whole square, right? So this is what we are going to use it over here. So to find the variance of y, we have variance of y means what? Variance of 2 times x. And we know using this properties of variance that variance of any constant a times x would be a square times variance of x. So variance of 2x would become 4 times variance of x, right? So variance of x is what? Expectation of x square minus x whole over expectation of x whole square, right? So whatever you get variance of x as, you multiply it by 4 and you should get your answer. So if we have to find expectation of x square, so this, how will you do it? You will do x square times fx of x.
Yes, ma'am.
Yeah, so x square times fx of x. This is how we do it, and we got our answer as 0.542. Then similarly, you find the expectation of x, which we had found in our previous problem, which was 1.402. And we solve for it, we get variance as 0.051. Multiplied by 4, we'll get our variance of y.
Ma'am, if you don't mind, can you go up, ma'am, little bit
Yes.
before the slide? Okay, here.
Huh.
Expectation of x is 1.4, ma'am, but when we applied here, it is 0.701 to the whole square. May I know what is that one?
0.7. Oh, okay. No, I think there's a typo over here. It should not have happened. It will be 1.
And one more question, ma'am. So as you in the question, it is given y equal to 2x, right? So we are trying to find the variance of y. So
We are
ideally,
trying to find the variance of y, right?
so it will be okay. We are multiplying variance of x into the 4. Okay. I thought that is correct. Actually, the 4
Yes.
multiplying is correct.
Yeah.
But we didn't multiply in the substitution, ma'am. That's what I got confused. Can you
We
come
didn't.
down? Next slide. In the next slide.
Yeah.
Yeah, this is the expectation of x square. So we need to multiply into the 4, right? 4 into something. This one. It has to be multiplied into 4, right?
It has to be multiplied. No, we are doing this
Okay.
multiplication of by 4 at the end.
Okay.
Yeah.
Ma'am,
Hmm?
ma'am, I have a doubt.
Yes.
Like instead of multiplying variance by 4, ma'am, can you scroll up, please?
Hmm.
Yeah, ma'am, for this expectation of x square, ma'am, what I did was I have taken the function was given as 2x. So I have
Hmm.
squared it and it was 4x square. And then I solved it, like integrated, and I was getting the same answer. So is it right?
Ma'am,
You did.
I also did same. I find expectation of y and expectation of y square.
That is also fine.
Like, ma'am, for the expectation of x square, instead of writing x square, I wrote 4x square.
Yeah. I mean, it is fine.
Okay, ma'am.
Hmm. I mean, everything is same, no? Overall.
Yes, ma'am.
Hmm. Okay.
Ma'am,
We'll
can
go.
you please explain what they did?
No. What they did is instead of doing expectation of ex square, expectation of x square, they did the expectation of 4x square directly. So that is not, I mean, it's the same thing. I mean, and even subtracting it like 4 by there.
Okay, ma'am, got it. Thank you.
Okay. So the last topic from week 5 that we had seen was like given a discrete random variable and a continuous random variable, how do we write the joint PMF, right? So we have already seen in the first and second week that if we have two discrete random variable, how do we write the joint PMF for that? So even in week 4 or week 5, we have seen, or maybe I think we have not seen it so far. Like given two continuous random variable, how do we write the joint PDF? But what about when we have one random variable which is discrete and another random variable which is continuous? How do we find the probability, the joint PMF in that case? Right? So what we are saying here is suppose x and y are suppose x and y are jointly distributed where x belongs to t of x. So here x is a discrete random variable, so the range of x is given to be t of x, and its PMF is px of x. And your y is a continuous random variable. Okay. So what we are interested in finding out, we want the conditional probability of x given this y equals y naught. Okay. So conditional, all of you know what the Bayes theorem is. So Bayes theorem says probability of x equal x given, let's say, y equal y is equal to probability of y given x times probability of x, right? Divided by probability of y. This is how we do it. So even here, so we have this condition probability, which is probability x given y. So this we can write it as f of y given x equal x times p of x divided by f of y. Okay. So this is just using the Bayes theorem, where one.
These two notations are same, right?
Which two notations?
If we can write this as same as probability that x given y is equal to y naught of x, right?
A probability of x given y.
Like if x given y is equal to y naught of x is the same as this notation, right? Probability of x is equal to x given y is equal to y naught.
You mean f of x given y, you're saying? No, I think
No,
I'm not
I'm
getting what
saying
you're trying to say. Can you repeat again?
this notation, the probability of x is equal to x given y is equal to y naught. This is this just same as f x given y is equal to y naught of x?
Yeah.
Okay. Okay.
So from here, like we have a question, some context-based question. So here, what we are saying is, suppose a person randomly chooses a battery from a store which has 30 batteries of type A and 70 batteries of type B. So you have two types of batteries, a type A battery and a type B battery. Okay. Number of type A batteries are 30 and number of type B batteries are 70. Now, let's say if I look at the battery of type A, what we are saying is that these batteries are exponentially distributed with average life of 3 years, and the batteries of type B are exponentially distributed with average of 7 years. If the chosen battery lasts for 5 years, what is the probability that the battery is of type A? So what is discrete here? I mean, What is this criteria?
Lifespan of battery
Lifespan of batteries.
and number of batteries.
When type A, type B, two types of
Choice of
battery.
the two type of batteries here is discrete. So let's say I can say I can define my x random variable as type of batteries maybe, and x takes takes a and b. It's something like that. So in this question, you have to find what is the probability that um, if you choose, if you select a battery, if you choose a battery, and that battery lasts for 5 years, what is the probability that it is coming from the battery of type A? Conditional probability question. But you will have to formulate this whole problem into like this discrete and continuous setting to finally go to solving the probability. Maybe just take a couple of minutes to think about it, and then we'll work out the solution. Anyone got the answer? Anyone got the answer for this question?
Ma'am, D option.
Hmm? Option D?
Yes, ma'am.
Okay. Anyone else? Now, anyone else solve this problem? No? Should I do it?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, maybe I will do it here. See, the question was a person randomly chose means there are two types of batteries, right? You have a battery of type A, you have a battery of type B. Now, how many batteries do you have of type A? 70 you have?
Ma'am, third.
30 and 70.
30 and
Yes,
70.
ma'am.
Then what's next? Um, battery, okay. Type A battery is 3 years and 7 years. Okay, let me just write this. Okay, maybe first I'll explain it over here, and if it is not clear, I can go back to the writing. So, okay. So suppose that like if, so the question asked you, if the chosen battery lasts for 5 years, what is the probability that the battery is of type A? So what you have to find is probability that selected battery is of type A, given that the battery has lasted for 5 years, was lasted for 5 years. So let's say I define my random variable y as the battery life. Okay, so you have to find what is the probability that x is equal to a, right? Given that y is equal to 5 years. This is basically what you have to do. Okay, so This is what you have to do. F of x given y equal 5 of 1. So 1 is basically, I think I'm just defining as this Bernoulli random variable. Okay, so there's nothing extra over here. So you just have to do, again, use the same Bayesian formula. So you will have f of x given y equal 5, which is f of y given x equal 1 times probability of x is equal to 1 divided by fy of 5, right? Can you mute yourself? Can you mute yourself?
Ma'am,
Yes.
why did you take in the parameter 1/3?
1/3. Where did I take 1/3? So okay, so let me write. So I can define one random variable x has the battery selection of battery, right? So A and B. So what is the probability of selecting the battery A? So this probability would be 70 by 100. And what
Ma'am,
is the
for type A is 30 and for B is 70.
for type A is okay, I've written opposite, is it? Okay. So type A is 30 and type B is 70. So probability of choosing a type A battery is going to be 30 upon 100, and probability of choosing a type B battery is going to be 70 by 100, right? Now let's define another random variable y, which is nothing but battery life. So let's define y as battery life. Now the question that is asked is, what is the probability that the battery is of type A? What is the probability that x is equal to A given that y is equal to 5, right? So if I use the Bayes theorem, my this probability is going to be f of y given x is equal to A of 5 times probability of x is equal to A divided by probability of y is equal to 5. So it's a density, so I'll just write it as a phi of 5. Okay. And what is f of y given x? So we should know what is this distribution, right? So if the battery was of type A, so if the battery was of type A, what okay, battery life was given to be battery life of type A is 3 and 7. Okay. So this was exponential 1/3, and if the battery is of type B, then its battery life is exponentially distributed with the parameter 1/7. Are you asking why this is 1/3, 1/7?
Yes, ma'am.
Yes,
Because
ma'am.
in the question, what is given to you is, look at this. The question says battery life of type A and type B are exponentially distributed with average life of 3 years and 7 years. So if you have an exponential distribution, let's say I have a random variable x that is exponentially distributed with the parameter lambda, then we say that the expectation of this x is nothing but 1 upon lambda. So here in this question, you are given the average life of these batteries, and we are saying these average, I mean, the battery life is nothing, battery life is distributed as exponential random exponential distribution, and their average is given to you as 3 and 7. So if the average of these exponential distribution are given to you as 3 and 7, it means my parameter is going to be 1/3 and 1/7, right? Is okay?
Ma'am, I didn't get it. Can you explain it again?
Okay. See, What I'm saying is, if let's say I have a random variable x, this x is not same as this x, okay? So let's say if I have a random variable x that is exponentially distributed with the parameter lambda, then what do we say that expectation of x is? This is 1 upon lambda, right? This you would have seen it in week 4. So in our question, we are given the battery lives. So we are saying y denotes the battery life, right? So if my x, if my chosen battery is coming from A, this is going to be exponentially distributed with the parameter lambda, let's say lambda 1. And let's say if the battery is coming from type 2, then its battery life is going to be exponentially distributed with parameter lambda 2. Now we need to know what is this lambda 1 and lambda 2. So in the question, it is given to us that this battery life is exponentially distributed, whose average is 3 and 7 for A and B respectively. So if the average is 3 and 7, right? So the lambda 1 and lambda 2 is going to be 1 upon 3 and 1 upon 7. Right?
Okay, ma'am.
Then only, so if y given x is equal to A is exponential, so if y given x equal to x is exponential 1 by 3, it means average, it means that expected value of this y given x is equal to A is 3, and expected value of this y given x is equal to B is 7. This is what is given to us in the question. Okay, this is fine. Now let's go back to solving our problem. So we saw that my y given x is equal to A and y given x is equal to B, they follow exponential 1 by 3 and exponential 1 by 7. Now, what can we write f of y given x is equal to A of y as? Can someone tell me?
And 30 by 100.
Sorry?
30 by 100 times 1 by
It
3
will be the
e power.
exponential distribution of
It will be
1
the
by
exponential 1 by 3. Yeah, because y given x is equal to A follows exponential 1 by 3. So its PDF is going to follow. So how does exponential distribution look like? Lambda times e to the power minus lambda x. So our case lambda is 1 by 3. So lambda times
1
e
by
to the
3
power
e power minus 5 by 3.
minus y by 3, right? Similarly, if we want f of y given x is equal to B, given this y, so this would be 1 by 7 times e to the power minus y by 7. Right?
Yes, ma'am.
We've got this. Now let's go back to this, our original question. This is what we had to find. So f of y given x is equal to A of 5. So just substitute 5 over here. So what will you get? You will get 1 by 3 e to the power minus 5 by 3 times probability of x is equal to A. So x is equal to A is 30 by 100, right? So into 30 by 100 divided by fy of 5. Divided by fy of 5. And what is fy of 5? This would be f of y given x is equal to A times probability of x is equal to A plus f of y given of x is equal to B of y times probability of x is equal to B, right? So this is going to be same as numerator part. And what about this? So we saw that our y given x is equal to B, their density is 1 by x. So this is equal to 1 by 7 e to the power minus y by 7. So y is since 5, so it would be 5 upon 7 times, what is the probability of B? It is 70 by 100 times 70 by 100. So what did we get? So we had probability that x is equal to um, a, given that y is equal to 5, which was f of y given x is equal to a times 5 into probability of x is equal to a divided by f of y given x is equal to a of 5 times probability of x is equal to a plus f of y given x is equal to b of 5 times probability of x is equal to b, right? And then our numerator was, it had come out to be 1 upon 3 e to the power minus 5 by 3 times 30 by 100, and the denominator is 1 by 3 e to the power minus 5 by 3 into 30 by 100 plus 1 by 7 e to the power minus 5 by 7 times 70 by 100. So I can just cancel all this, right? And 1 by 10 I can take outside. So I would get e to the power minus 5 by 3. This also gets cancelled out, divided by e to the power minus 5 by 3 plus this gets cancelled out, and you have e to the power minus 5 by 7. Okay. So what I can also do is I can just divide numerator and denominator by e to the power minus 5 by 3. So doing so, I will get 1 upon 1 plus e to the power minus 5 by 7 divided by e to the power minus 5 by 3. I mean, you can also skip this. So what will you get? You'll get 1 plus e to the power minus 5 by 7 plus 5 by 3, right? And what is this? This is 21, 7 times 3, which is, sorry, 5, 3, 15 plus 7, 5, 35. So what do you get? This as 1 upon, so the final answer would be 1 upon 1 plus e to the power 20 upon 21. So this is the answer. This is probability that x is equal to a given that y is equal to 5. Okay. Is this clear how we solve this?
Yes, ma'am. Ma'am, could you please scroll up?
Hmm?
Okay, ma'am.
Okay.
Ma'am, in numerator it is 30 by 100 now.
Yeah.
So there 1 by 10 would be left. And
So see, in the numerator, what I have done is, so in the numerator, my 1 by 10 is coming as constant.
okay, you're taking common from numerator and
And even
denominator.
from the denominator, I can take 1 by 10 constant.
Yes, ma'am, understood.
Ma'am,
Yes.
lifespan of type A is 3 years, but you have written a 1 by 3 taken as exponent parameter.
What? This part is it? 1 by 3 and 1 by 7.
Yes.
I had explained this, right? So in the question, you are given the average of this exponential. So we know that if you have an exponential distribution, its expectation is 1 upon lambda. So if the average is
Okay, ma'am.
given to be 3, then actual parameter is 1 by 3.
Okay, ma'am.
Okay.
Thank you.
Ma'am,
Hmm.
it's quite lengthy. Are we going to get such questions in exam?
I don't know. It's close to this far, no? I mean, you have, it's not lengthy, I would say. I think I have written it quite so many steps. Yeah.
But even then, it involves lot many steps and calculation. And if we get like 2, 3 questions like this, so it would take a lot of time.
Mm.
Ma'am,
So,
can I please ask, the quiz one paper was set by you?
quiz one paper was set by me, not entirely
Yes.
me.
If you are okay, I mean, if you are comfortable to share that information.
No, why is that? Why do you ask?
No, I was just wondering because that had like quite a few tricky questions, and none of the previous year question had such kind of question level. I mean, difficulty level, I would say.
Yes,
I
ma'am.
don't think all the questions were tricky. No, I think a few, maybe one or two, maybe tricky. Which question you found to be
Ma'am,
tricky one?
it's you.
Ma'am, there were many, not just one. At least I found three, four questions tricky. I don't know what others. But for me, I found like at least few questions were very tricky.
Okay, let
I
me
found all
For
tricky.
example, there was
let me go back to the question. I think quiz one has been discussed, right?
Yes, ma'am.
that's fine, ma'am. Please stick to your schedule. I don't want you to discuss again. I was just wondering that you said the question paper.
Ma'am, one doubt regarding week 6 deadline, ma'am. Will there be an extension of any chance on week 6 deadline?
No, that doesn't look possible.
Ma'am,
Week
that
six is
we
going to
we
be.
still now we haven't finished week 5, ma'am. It's so difficult to do.
Yes, ma'am. Yes, I agree. Yeah.
Ma'am, week 5
But
is quite tough.
if week,
At least if
then we'll
Friday, if
find
we get,
week six more tough. I would say week six is more tough than this for
then
sure.
we will need more
And
time
then
then.
how will we do it in
Seven.
Yes, ma'am.
See, if we extend the deadline for week six, then see again week seven will be delayed, and then quiz will come. No, again week eight will get delayed. Week seven, week eight is quite difficult. I would say,
Ma'am, at least
like
on
because
Friday, if we can get like 2 days of extension, it will be great for week 6.
mm, I can check. I can check and maybe I can update you by Monday, but not very sure if it's going to happen.
Okay, ma'am.
So you can.
Ma'am, is
Hmm.
there
Sorry, can you
is
repeat?
there week 12 in states? Week 12 is there week 12 in states too?
Yes, there is week 12 in stats too.
At least the extra activity can we
Okay, ma'am.
extend,
Then it
ma'am,
will be.
because we can't. I mean, can't handle everything like week 6 also, and the extra activity also, like takes
Okay,
the.
I will talk about it. If it is possible, we can extend.
Okay, ma'am. Thank you, ma'am.
Yeah.
And then could you please suggest some other book or some channel where we can do more practice for
Um, for week five.
yes, ma'am.
For week five, there are. Did you look at the tutorials question?
Yes, ma'am. I mean, whenever I look, I have like I find no clue like how to start, and then that's it. After some time, I
Okay.
get like some clue, but then I get stuck in the next step. And when I
Uh,
proceed, it's like same
hmm.
story for every question.
So week five. Okay. Week five. Can you tell me the topic which you're finding to be difficult?
Actually,
Ma'am,
ma'am,
in one of the
Hmm? Go
tutorials,
on.
like there is a topic which was not taught in week 5 content, like marginal distribution of continuous variables and joint PDF.
Ma'am, it's there in lecture 5 and 4 now. Marginal.
We didn't get marginal distribution, right?
Um. Okay. Let me check. Wait. Week five, right? You're talking about week five. I would not suggest going to many places and solve the problems. I think the problems that you have in the activity practice graded and tutorials, I think if you
I mean,
solve
at
those
least the
problem,
concept,
you should be
if
able
you
to
could
get a
something for concepts,
what you
for
can
the
you repeat?
concepts, for the concepts, if you can please suggest some books, some reference book.
Um, John A. Rice is one book. You can look over. So John A. Rice is a book that we will refer for from week 7 onwards, but it also has like all the topics from week 1 to 4. So you can refer to John A. Rice also.
Is that already available for us?
It's available on it's available online.
Okay, ma'am. Thank you.
Okay. Which question you're talking about? For from tutorial week 5,
From tutorial 3, ma'am. They
tutorial
are
3.
using
Okay.
marginal distribution and double integrations, which was not in the lecture topics.
Double integration. It is not there. Don't say it.
Like from week 3 onwards, the third tutorial onwards.
Week 3 onwards or week 5 tutorial 3.
The tutorial 3 video where
Oh,
they
you're talking
solve
about
the
video.
problems.
Okay. Tutorial 3. Okay.
They were solving using double integration and marginal distribution of continuous.
Oh, wait. Okay, actually, this tutorial is not for week 5. This is for week 6. If I pointed it out, it is the week 6 content. So we'll get it moved to week 6. It is not week 5. Okay.
All the
Okay.
tutorials or just that tutorial video, ma'am?
I think the videos, tutorial videos, I'm not sure. So week 5 tutorial 1, week 5 tutorial 2, week 5 tutorial 3. The last three, they're correct. Just the video alone, I need to look at what all questions are not part of week 5. Okay. So many are from week 6. So do not worry if you have not studied week 6. So few of the questions from there will get moved to week 6. Okay.
And ma'am, I think tutorial 4 also is not a part of week 5.
Yeah, I think week 3 onwards, it would be week 6, I guess. Sorry, tutorial 3 onwards, it should be week 6.
Ma'am, the lectures now, tutorial lectures,
Hmm.
you're referring to that now?
What?
Ma'am, that tutorial lectures or that questions?
So there are tutorial videos, right? So
Yes, ma'am.
from third tutorial onwards, it's all week 6.
Okay, ma'am.
Yeah.
Ma'am, to solve all the graded assignment, what is the prepared one? Whether we need to watch the lectures or tutorial or both, or what is that one? Means
See, lectures are for you to understand the concept. Okay. So if like you watch the lectures, so after each lectures, we tell you to do the activity question, so that after every lecture you watch, like the very quick question, the easy questions, you can just solve it and see whatever you have watched the video, whether you are able to apply it, whether you're able to use the concept to solve the problem. So that's why the activity questions. Yeah. So solve the activity questions. If you have any doubt in there, you ask us. Then you have also the tutorials. So tutorials have like are split topic wise. So tutorial one, if you look at it, I think it should have the monotonic differentiable function, the questions from that part. Then tutorial 2 will have the questions from expectation part. Tutorial 3 will have this questions from this mixture distribution, like discrete and continuous. So tutorials are divided topic wise. So if you want to practice question topic wise, you can go there and do the questions. So tutorials also have the solution given to you over there, and you have practice assignment, solve the practice assignment also, because the more questions you solve, it gives you more confidence if some new questions come up. Yeah.
So, ma'am, in tutorial, only the 3 videos we have to watch for this week, right, ma'am?
Only the first two.
Two?
Yeah, only the first two. When the third is going to week 6.
Okay.
Yeah. So,
Thank you, ma'am.
yeah.
Ma'am, which week is the toughest for stats 2?
For stats 2, from week 1 to 6, it's not, if you are familiar with double integral, if you have done double integral, week 6 is not very tough.
Ma'am, overall stats to how many extra activity will be there, ma'am?
Sorry, can you repeat?
For stats to how many extra activity will be there overall the course? Like one.
I think I think 6 or 7.
Okay.
6 or 7 would be there, I think.
Ma'am, that is really too many, ma'am.
But that is a lot. I'm not sure about the number. I think maybe 6 is the upper cap. I'm not sure.
Ma'am, for working persons, like we have hardly weekends, and we have to study 3 courses. Within 2 years we need to clear this first year, this one. So I don't know how we can manage these things. It's really hard. Usually we will not clear like a 90 plus or something. Usually we'll get only average marks, and with that one, at least this extra activity will help to increase some level. It's really good because extra activities is actually giving the real time use cases. That is really good. But whereas
Yeah.
these exams and all those things, it was very depth, which we by seeing the lecture we cannot clear. By seeing the tutorial also we cannot clear. You have to practice, like study for 10 hours, that practice for 30 hours, then you will be at least able to understand the question in the exam. This is what happened in the quiz one. I thought
Okay.
you can clear the exam very easily with your at least it helped me for the revision session as well as the revision of video and everything. I just got pass. That is the truth.
Okay.
Though it was the we have studied in the college, even I cleared the engineering and everything. Again, it is studying the same subject. For us, it is really hard to remember and everything. To seeing the question itself, it is very hard. So this stats 2 and max 2 is giving more time this time. I don't know.
Yeah. So generally, like even before the course start, we always say that stats 2, maths 2 is tough. It's a tough course.
Maths
Python.
was fine, ma'am. It was
Yeah.
I found it very
Okay.
easy compared to test.
So no, many people find stats 2 a little easier. Some people find maths 2 a little easier. But from previous terms, what we have observed is many students have told like stats 2 is difficult. So even we say before the starting only that's a difficult course. You will have to spend a little more time because complete new topics you are studying over here.
And you know what, ma'am? The real difficulty is this pattern of exams. One day we have to. Usually in engineering, we'll write and read for one subject at a one day. Okay, but for this day, this time we will be enrolled for 3 more courses, and in a single day you need to do all the subjects. You got it right. So
Yeah.
you need to revise that 3 subject in a single day to clear that one. That is
Yeah.
that You know, it was really, really,
Yeah,
I
it
would say it is
might be
really,
difficult. Yeah, it might
regular
be
student,
difficult.
it
Yeah.
for them, they will write a exam and at least they will get a partial marks. Whereas here, if you are choosing
Mm.
some one wrong answer, you are losing entire marks. Though you cleared at least, out of three, it was two is correct, one is wrong, but
Then you lose the marks.
lose the
Yeah.
marks. So there is a no partial mark. Partial marks, at least, there is a one good thing is there is a no negative mark. That is really good. But
Yeah.
when I compared with the regular student and this one, this is really toughest, to be honestly speaking.
Okay. So we'll try to see, like, maybe.
No, one
Yeah.
more thing, as a working professional, I'm more interested in the subject, right? So that's also there is there any method to verify the answer which is coming? That is
Verify the
not being
answer.
taught.
So.
Yeah, that is, for example, probability will always be less than zero. Less than between 0 and 1, right? Sorry. Like
Hmm.
expectation or variance, can you put a small graph or something like that to quickly check whether the answer has correct? For example, Chebyshev's
Hmm.
inequality, right?
Hmm.
So
Yeah.
those kinds of alternative, see, imaginative thinking is not coming out. That's if that is being taught, no, it will be easier to. Some people understand, working out. Some people understand the geometry behind it, right? So, for example, I understand calculus and the geometry behind it. I'm not so texture actually, right? So,
Hmm.
for a problem, in mathematics there are two or three ways to solve it, right?
Yeah.
So, if that approach is there, then then we are able to then that will stimulate a lot of thinking actually.
Hmm.
So that's my if in these sessions, if it that kind of thinking, if it can be stimulated, it will be very useful. So that when we
Okay.
go to the exam also, right, it will be
Hmm.
a we can verify our answers quickly.
See, in stats, geometrically, not everything can be solved. That is one issue. But there are few topics that where geometry will definitely help. So, week 6 is where like you have your. It's going to be more like calculus, I would say. Week 6. It's a function of two variable. So maybe okay. We'll try to set up like in these sessions. We'll try to do uh, focus more on the concepts, right? We'll try to do such parts.
No, even in a continuous distribution,
Hmm.
it's going to be double integration, right? Even there,
Hmm.
you can teach on the GeoGebra or saying that this is the distribution. So we are taking only the particular interval, like that, so that it will stimulate the thinking better.
Okay. Okay. Yeah.
Thanks. Yeah.
Hmm. Yeah. Okay. Yes, Tisha and Bhumika.
Ma'am, I have doubt in that conditional. I'm not able to solve those questions, ma'am. Can you
Um,
explain?
I have also doubting activity 5 and 4.
Can you
do-
explain that again?
what we did the last question.
No, ma'am, just formula.
Just the formula.
Yes, ma'am.
Okay.
Ma'am, how to speed up?
How to
Actually,
speed up the
yeah,
preparation
but yeah, generally, for the first time, it will take some time for us to solve these activity questions. But in the
so
exam, we have the time constraint, right? So
okay. So,
comparatively,
one
this will,
question. So, like, how much time does it generally take for you to watch one lecture, or let's say watch the whole content?
content.
Mm.
Uh, actually,
Including watching and writing the notes along with it, it takes approximately 1.5 hours.
For one lecture?
yeah, yeah, 1 hour
Yes, ma'am.
to, oh yeah,
Because one lecture is itself 45 minutes, and
And
writing notes along with that is pausing, writing, and pause, writing. So that takes half an hour extra.
and, and then if we get some doubts in the middle, then it'll take even more time to finish, ma'am.
Yes, ma'am.
Yes, ma'am.
We'll search it on other sites. We'll try to find the clarify the doubt, and then it takes 1.5 hours for each lecture.
Ma'am, it is possible that you can increase TA sessions to for practice questions. Like the week
Uh,
6 and week 5s are very tough. So
yeah. So okay. One more thing. So like when you have TA sessions, I think the first session that happened for any week, what I have heard is like you have not watched the lectures by then. So maybe it's good to like do the problems from the previous week in the first session and something like that. Like both sessions, like let's say we have two sessions, we keep both the sessions as problem solving. Okay. So you get so that you get more practice on doing the problems. We can have some problems like problems that has come previously in the quizzes and some problems from your assignment and tutorials. We can mix those problems and maybe we can have two dedicated sessions just for problem solving. Would that help?
yes, ma'am, it would be really
Yes, ma'am,
helpful.
that would
Well,
help. If you take problems from the assignment, then it will make us easy to solve the assignments problems, the
but
graded
the thing
assignment
is,
itself.
you should try doing the problems first yourself also, because once you look at the problem, you should first gain that skill to like understand the problem and solving it yourself. Then only you will get some confidence when you get some new question, right? So first, even like before coming to any live session or any TA session, whatever you attend, I think it would be good if you look at the content and also like try to like have looked at some problems and try to solve it. Then it would help you more, I would say.
Ma'am, but generally TA sessions are on Thursday and Saturday, so
Hmm.
hardly we can solve all the activity questions. Like
Yeah,
deadline or
maybe topic wise. We'll do topic wise, not everything. Means some part of it, right? Let's say just one topic. Even if just one lecture question, if you are ready with, I mean, let's say if the session happened on Thursday, you have watched only one lecture, you have solved only problems from the first lecture. That is good enough to like start with.
okay, ma'am.
Okay. What is the doubt?
Ma'am, can
Ma'am,
you give some
one more
suggestions?
thing while registering for the course,
hmm?
they say approximately 10 hours is enough for this course, but it is not fair, ma'am. Per week, 10 hours is not enough for doing stats too.
Per week, I think it says 12 to 14 hours, right?
No, while we are registering for the course, usually there is a question: how many hours will you be able to spend? And then, so
Okay.
so if you say 20 hours, you get two courses actually.
Oh, okay. So, yeah, like before the course registration, we have always said like, uh, if you are taking two courses, pick one course which is lighter and one which is heavier. So, but the SEM two courses like Maths 2, Stats 2, Python, these three are quite heavy courses. So Python was because of this OPP, it becomes a little difficult, and stats it's complete new topic. That's why it becomes difficult. Maths also it's a different way of studying the topics. So like students have found it difficult. So that's why even we like before the course registration, even we suggest that if you are taking those courses, be like be very be sure that you are able to spend this much of time in when you take this course, because it's going to take time to understand it.
Ma'am, that's fair enough.
Hmm.
However, I think the point that is being made is while the recommendation is for every 4 credit course, like statistics 2,
Okay.
the recommendation is plan to spend 10 hours of per week.
Hmm.
Uh, what we are finding is probably those 10 hours are not enough. It seems to be more demanding. As you
Yes.
said, this is new and a very new set of concepts and being introduced,
Yeah.
especially problem solving. Yeah, the TA sessions are very helpful.
Mm.
Ma'am, we want to spend more time, but we
I'm
don't.
sorry, I
We're
think I
not able
interrupted
to.
somebody.
Yeah, I can just continue with that thought that it's a bit misleading. 10 hours per week is not enough for this. So it's like it's a bit misleading before we enter into it, because students, they don't know. We feel that okay, 2 subjects, 3 subjects, we can do it, but then
Mm.
once we have taken it, we are under pressure to
Complete
perform.
it.
And
Yeah.
Python being an interesting subject, stats 2 being a very interesting subject, we want to spend more time, but we're not able to spend more time. So that becomes like that.
Yeah. Okay. Maybe I think I was not aware that like before you do the course registration, you are asked this question, because when we say it's generally 12 to 14 hours you should be able to spend in per week here.
Even during the
Yeah.
meetup, when Andrew sir and Bharti ma'am had come, even then he was saying like, stats 2 is very demanding and 10 hours are not enough. But then
Yeah.
that is, we are not made aware of it before we select the course. Once we are entering the course, then we realize then 10 hours are not enough.
Mm. But various orientation session happens, and many different session happen before the course registration thing. But I think it should be specifically given.
Yes, ma'am.
Will
Yes, ma'am.
Yeah, like not everyone can attend the sessions, and that's really true. So we'll make sure that at least during the course registration it is made clear from the next time.
Thank you, ma'am. Thank you.
One small help means as part of this course, do we have any consolidated notes per week so that in the max wise they have there is a very good kind of book or notes. It was very easy. We don't need to spend on the time to take a notes or something. It just keep it as aside and we can watch.
Mm.
So similarly for a statistics, do we have anything like how you are teaching today, right? There is a PDF, and for the solvers there is a very very easy for us. For this week there are three concepts. So
Hmm.
whenever even in the week 1 to 4 also you thought the same. And the week 2 there was only 3 set of problem for the conditional problem, and then everything, it was very clear like that. Do we have any notes or PDF so that we can refer and download?
We have short notes. Like short notes are like every topic. It just the summary of each topic. It's quite short. It is more like revision for your once you have watched the particular week, then it's useful. We
Yeah.
have such kind of notes, and generally these like the sessions which we take live, these notes we get it uploaded on the portal only. Mm, but from the previous terms we should have it,
Yeah.
and yeah, okay, if it is there, we'll get it uploaded. So
Thank
in maths, what kind of notes do you have, like handwritten notes or?
No, it's actually manually typed. Means it's very written and typed
Hmm.
course. It looks like a book. Whatever they thought in
Okay,
the
okay, okay,
lecturer
okay,
course, it was
okay,
very,
okay.
very, it was very, easily correlate. Whatever
Yeah, yeah, okay.
lecturers
So
were
we
teaching.
have it. Yeah, yeah. So we have it for I think some 7, 8 weeks. We have it. So we'll get it uploaded.
Thank you, ma'am. That will be really helpful.
And ma'am, also in acegrade.in, there are notes for every subject prepared by students. So it is also helpful.
Which course?
Ma'am, acegrade.in, that site, there are
Uh,
notes also for every subject.
I don't know. Can you repeat?
Acegrade.in, ma'am, the site which actually has previous year
Okay, okay,
question paper and
okay.
page.
There is some site where students have posted their notes, handwritten notes.
Yes, ma'am.
Yeah. So maybe yeah, that there also you can refer to. But from our side, we will upload whatever notes we have available with us.
Yeah. Thank you. It will, if it is there, it will get uploaded in the supplement contents, right?
Yes, it will be uploaded in the supplementary content. Yeah.
Okay. Thank you.
Ma'am, how to improve our speed in exam perspective?
How to?
It, how to improve our speed? Like, ma'am, what happens is that we revise 1 to 4 weeks only. There, in the quiz, they don't ask like activity questions or practice questions. They ask previous term questions or week 0 questions. So it takes
Weeks.
some time to remember and um, it takes some time. So how to speed up? We have
Yeah.
to remember. It's been
Um.
2 months we have completed SAS one.
Yeah. So you have to uh, practice. You'll have to practice. I think that's all it will take. Uh, you will have to practice questions. So
That will
the
speed.
book I have suggested, right, John A. Rice. You look at this book also. Yeah. Uh,
Can you
it's
please give the link so that we can see and
it's online. You just search the name of the book. I'm not sure, but search this, statistics book by John A. Rice. You should get the textbook. It's quite good. I mean, we'll refer this book for from week 7 onwards or week 9 onwards. I think maybe week 9 onwards, I guess. But all the concepts from week 1 to 6 is also there. So you can refer to this textbook also.
Ma'am, can you spell the
It's all
name?
John A. Rice. John A. Rice.
Ma'am, University of California is
Um,
in mathematical statistics.
yes, mathematical statistics. Yeah.
Okay.
Ma'am, can you please explain this? The
Uh,
conditional one.
yeah. This right? Yeah. Okay.
Ma'am, the formula, I'm not, this question I understood, but
Okay. See, if you have a formula, right? So let's look at the Bayes theorem, right? So you have, let's say, two events, A and B. So if I want to find the probability of, let's say, A given B, okay, what do? You write probability of A intersection B divided by probability of B, right? And A intersection B, this you can also, so if you write probability of B given A, so this is what probability of A given B divided by probability of A, right? So you can write your probability of A intersection B also as probability of B given A times probability of A, right? So in place of this, I substitute it over here. So this becomes probability of B given A times probability of A divided by probability of B, right? This is what Bayes theorem says, correct?
yes, ma'am.
Now, this is conditional probability. Okay, Bayes theorem, you have different events and all are disjoint. So there only. So it is. So now in our case, you have X random variable. You have the random variable Y. Now you have to find what is the probability that X given Y. So what will you do? It will be probability of Y given X divided by probability of Y, right? This is what you will do. Sorry, Y given X times probability of X is equal to X, right? This is what you will do.
Yes, ma'am.
Yeah. So since Y was a continuous random variable and its PDF was given to you as Fy of Y, so in the denominator, I write this as Fy of small y, okay? And in the numerator, you have f of y given x. So probability y given x, right? So f of y given x of y times probability of x is equal to x. Now, see, so what is probability y equal y? So since so we have this distribution, right? Y given x is equal to a, y given x is equal to b, right? Given that we have observed a particular value of x, what is going to be the distribution of y? Or like even you have seen law of total probability. So if you have to write probability of a, what will you write? You will write probability of a given b times probability of a. I mean, here it is just 2 even, so no, it's not right. So let's say if you had x1, x2, I don't know, what do you use? Do you use x1, x2 in Bayes theorem? Maybe it's okay. x1, x2 up to xn. Or okay, do you know law of total probability?
Yes, ma'am.
So
Yes,
probability of y, what can you write? You can write probability of y given x is equal to a times probability of a plus probability of y given that b has occurred times probability of b.
Yes, ma'am.
Right? So that is what we are doing over here. So this is just the total probability. Is this formula clear?
Okay, ma'am.
So your week 5 deadline is this Sunday.
yes, ma'am.
Okay. Okay. Fine.
Excuse me, ma'am.
Hmm.
Ma'am, I have one more doubt.
Yes.
Ma'am, in week 5, there were intervals given like minus pi by 2 to plus pi by 2, and we were supposed to calculate CDF, like x lies between minus pi by 2 to plus pi by 2.
Okay.
So, ma'am, for calculating CDF, ma'am, sir was integrating from minus pi by 2 to x, not to pi by 2. So, is it like that for CDF we have to integrate only up to x?
Wait. Can you repeat your question? You have the question what?
Ma'am, like x lies in the range of some minus pi by 2 to plus pi by 2.
Minus
Pi.
pi by 2. Okay. Okay.
Now some function was given and we were supposed to calculate CDF of this.
Okay,
PDF was
maybe some
given.
fx is given to you.
Yes, ma'am.
Fx is something where x belongs to this. Now the question is, what is fx of x? So what is fx of x? It says integral of fx of x dx, right?
Yes, ma'am.
And what is CDF? CDF is the probability, right?
Yes,
What
ma'am.
is CDF is a probability, and it is the function from basically real number to 0, 1. Right? So if I have my real line, so see this would be from minus infinity to infinity. Okay, sorry, x lies between minus pi by 2 to pi by 2, so you will take it there. But what does this will give you 1, right, if you do
Yes,
this,
ma'am.
because this is a PDF, and if you integrate your PDF over this whole support, you should get 1. So
Yes, ma'am.
what does the definition of CDF says? It says this is equal to probability that your random variable is less than equal to small x. Okay, so this probability is going to, like, how will you calculate this probability now? You will integrate, right? And you will integrate what? What will you integrate?
Minus pi by 2 to
No,
x.
what will you write over here?
Fx.
You will write
Yes.
fx,
Yes, ma'am.
fx of x dx. So you will write fx of x dx. And what is the range of, what is the lower limit?
Minus pi by 2.
Minus pi by 2. And what is the upper limit?
It will be x.
It will be x. Why? Because your capital X is less than equal to the small x. So your random variable is taking the value at most x, right? So like in the discrete case, what you used to do? So whatever jump you have, I mean, from there you used to find uh, the probabilities or PMFs, right? In discrete case, the jumps. And if you have to find the CDF, so you will add all the probabilities that is below this particular value. This is what we used to do
Yes, ma'am.
in case of a discrete random variable. So if it was discrete random variable, we used to, like, let's say my x takes the value 0, 1, 2, 3. Okay. And if I have to find fx of maybe 2. So this is, by definition, this is equal to probability that x is less than equal to 2, right? So I will add all the probabilities for which my random variable takes the value less than equal to 2. So it will be probability that x is equal to 0 plus probability that x is equal to 1 plus probability that x is equal to 2. So you added all these three probabilities, right? So if I, so if you have some general x, you don't know what this small x is. So if you have some general x, the lower limit you know because you know the support for x. So you know this lower limit, but max it can go to this x that is given to you. So that is why the limit is from minus pi by 2 to x. Uh, is this your question? Was this your
Yes, ma'am.
question? This
Yes,
was the
ma'am.
question. Okay.
So, ma'am, for every CDF, we have to integrate lower bound to x.
Yes.
Okay, ma'am. Thank you, ma'am.
Okay.
Ma'am, I have a doubt in activity 5.4, question number 2.
Activity 5.4. Question number?
Ma'am, question number 2.
Question number 2. Okay. AQ 5.4. What does question number 2 says? It says you have x following the binomial distribution with n equal 2 and p equal 1 by 2. And we are given that, so what all values x can take? So x can take, since n is 0, can take
Ma'am,
0,
0
1,
and 2.
2. Now what is also given to us is y given x is equal to 0. This follows a normal distribution with mean 0 and variance 1. Then y given x is equal to 1. This follows normal distribution with mean 1, variance 4. And y given x is equal to 2 follows a normal distribution with mean 2 and variance 9. Okay, this is the question given to us.
Yes, ma'am.
Now you have 4 different options and you have to select which one is true. So if I look at the first option says what is f of y given x is equal to 2 of 2. Okay, so this is what, this is f of okay, so you are given that y given x is equal to 2 follows a normal distribution with parameter 2 comma 9. So you know that this, let's say if I talk about any general y and any okay, let it be 2. So this will follow, so this PDF would be, so what is the PDF of a normal distribution? So let's say if I'm saying
And
My
1 by sigma.
Yeah, if my x follows normal with mean mu and variance sigma square, then fx of x is nothing but 1 upon sigma under root 2 pi e to the power minus 1 upon 2 x minus mu upon sigma whole square, right? So I know that my y given x is equal to 2 follows a normal distribution with parameter 2 comma 9. Then this probability would be nothing but 1 upon sigma. What is sigma? This is 3
Ma'am, 3.
under root 2 pi e to the power minus 1 upon 2 y minus, what is mu?
Ma'am,
2
2.
divided by 3 whole square,
Yes, ma'am.
right? So you just substitute what? You'll have to substitute now. Now the question is, the first option is f of y given x is equal to 2 of 2. So this, you just substitute y to be 2 over here, substitute 2 over here. So 2 minus 2, it will be 0. So e to the power 0 is 1. So you will
Yes,
have
ma'am.
only 1 upon 3 under root 2 pi. So my first option is correct. Okay. Now
Okay,
if
ma'am.
I look at, similarly you can do option 2. Option 2 is f of y given x equal to 0. So I know my y of y given x is equal to 0. This follows a normal distribution with mean 0 and variance 1. Then my PDF for that. So if I have to write,
Okay, ma'am, I can do it.
you can do it, right?
Yes, ma'am.
Hmm.
Ma'am, could you please
Ma'am,
explain last option?
Last option. So the last option is f of y of 2. Okay. So this is what? This you can write it as f of y given x is equal to, x takes 3 different values. X is equal to 0 of 2 times probability that x is equal to 0 plus, or I can just maybe do some over here and let's write it as some k. Let's write it as some k. So k varying from 0 to 2. Fine. This is fine. And this would be what? This would be f of y given x is equal to 0 of 2 times probability that x is equal to 0 plus f of y given x is equal to 1 of 2 of probability x is equal to 1 plus f of y given x is equal to 2 of 2 probability x is equal to 2. Sorry, yeah, fine. So the way we solved for the first part, we can do it individually for these three. One part we have already solved. This we have already solved in the first question. You just
Yes,
have to
ma'am.
multiply it by probability x is equal to 2 here. And even y given x is equal to 1, we have solved. And similarly, you do for y given x is equal to 0.
Okay, ma'am. Thank you.
Okay.
ma'am, can you explain the last question of 5.4?
The last question of 5.4.
Ma'am, before that, can you also solve question number 5 of this question? And
Question number?
question number 5.
Question number 5 of the same activity.
Yes, ma'am. Ma'am, question number 4, 5, and 6 are related, so that's why I asked.
Okay. So, all right. X is given to you as uniform. X follows a uniform distribution with uniform minus 101. Z follows a normal distribution with parameter 1 comma 2. X and Z are independent and you're given y as x times z. So, okay. So you have to solve for, okay, question number 4, you have for, now here, see, my x follows uniform with with the values -1, 0, comma 1, right? So now let's say if I put x to be -1, then what is my y? This is z, sorry, minus z, and minus z would be normally distributed with mean shifted to now -1, variance as 2. Let's look at this graph. So you have this normal distribution. Okay. Now, see, z is centered at 1. Now, if we talk about minus of z, so minus of z would also be a normal distribution, but the mean will be shifted to -1 now. Is this fine?
Variance won't be affected.
Variance won't be affected because we are just doing from z, we are doing minus of z.
Okay, whether we
So,
translate or scale, variance
so
will be
it will,
unaffected.
yeah, it will only translate, no? So y would be, so let's say this is, okay, maybe, let's say this is centered at 0, okay? Now if I do 1, so I'll have my mean somewhere here, centered at here, okay? So this was my z. Now if I take minus of z, so minus of z would be centered at minus of 1. So we are only translating, right? So if we are only translating,
Isn't it scaling? Like we are multiplying in x and z.
we are multiplying x and z, right? So x was -1, so y becomes minus z. And since z followed normal with parameter 1, comma 2, so my minus of z now it would follow -1, comma 2.
Ma'am, but what if x was uniform with some 2 or 3 value in it? If x
Yeah,
was
so
2
x,
and
x
3,
yeah, x is no, x is uniform -1, 0, 1. So
No,
this
mm,
is
I
just for the
think
value -1. Now what happens if x is equal to 0? What would y be? Y would be just 0, right? What happens if x is equal to -1? Y would be just z. So this would again be normal with mean 1, variance 2. You're saying
and
what
what
happens if
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 yes, yes, ma'am.
x takes, let's say, some value 2. Suppose x takes value 2. Then y would be 2 times z. So how would the mean of this, sorry, 2 times z, no, not x, 2 times z. So if, let's say, my expectation of z was minus, expectation of z is 1. Now in place of z, I have 2z. So what will the expectation? 2
2.
times expectation of z.
Yes.
So how would y vary? So y would also be normally distributed with mean now 2 times the mean of z, which is -2, and variance 2.
And variance will
Will the
also
mean
vary,
be
right?
Sorry, can you repeat?
Variance will also change, right? Because variance of 2z will become 4 times variance of z.
So what is Okay, we were saying variance of z was variance of z is where is it?
It's given that variance of z is 2.
2. Now, yeah, you're right. Variance of now 2z would be what? 4 times variance of z. That would be 8. So
So the
now this would be,
distribution will
yeah,
change the
yes,
variance.
it will change. It will change. Yeah, right.
Ma'am, for x is equal to 2, why did you write y for y normal?
For
Like, I
x,
understand 8, but why minus 2?
wait, for x is equal to 2,
Yes, ma'am.
x is equal to 2, what's the ratio? So if I write x is equal to 2, my y would be 2 times z.
Yeah, ma'am, but why did you write minus 2? I didn't get that.
Oh, sorry. I think I saw this as a z distribution. Yeah, it is 2.
Ma'am, could you please explain for x is equal to -1, y is equal to -z, how you take expectation as -1 and the variance is 2?
Okay. So if I look at this, my y is equal to minus z. Okay. So expectation of z is 1, variance of z is 2. Okay. So expectation of minus z would be minus of expectation of z, which would be minus of 2.
Yes, ma'am.
What will be the variance of minus z? It will be minus 1 square times variance of z, which would be nothing but variance of z, and variance of z is 2. So that is why it is,
Okay,
sorry, it
ma'am.
is 1. No, it is 1.
Yes, ma'am.
Expectation was 1. So this is minus 1. Okay. So similarly, you can do for the other parts. This is fine.
Yes, ma'am.
Okay. Now, so the question is, what is the distribution of y given x is equal to 1? This was 1, no? This was 1. So now you know this is normal with 1 comma 2. So this is correct. What is y given x is equal to minus 1?
Ma'am, I'll try to solve this. I got it right now.
Okay.
You can go with the last question.
Ma'am, sixth question, first option, ma'am.
Sixth question, first option. So sixth question is, so this is the last question I will take. Um,
Okay, ma'am.
yeah. So question number 6 is first option, right? Only first option you want. So first option is f of x given y equal 1 of 0. So what is the distribution of, so okay, what is the distribution of x given y equal 1?
Related to fourth question only, ma'am.
Yeah, it is related to fourth question. So this is what? This is f of y given x is equal to 0 of 1 times probability of x is equal to 0 divided by f of y of 1, right? Now y given x is equal to 0. So from here, so given x is equal to 0, I know that my y given x is equal to 0, this is just 0. So this becomes 0, right? So if this becomes 0, the whole thing becomes 0. Is this okay?
Which one, ma'am?
The first option in question number 6.
Yes, ma'am. X
This is
equal
fine.
to Z.
So this is first option. Now if I look at second option,
Ma'am,
hmm,
can we just say that if x will take 0, then y can never be 1, so the probability that x given
what? Can you repeat?
Ma'am, can we say that if we have given that y is equal to 0, then x will never take 0. So that's why the probability that we have given that y is 0, x would never
I
be
think your voice is breaking. You are asking about this part.
Ma'am. Ma'am, I was saying that can we just say this if y is given to be 1, then x can never take 0.
If y is given to be 1, x can never take 0. Yes.
Oh, yes, ma'am.
Yeah. So the next option is f of x given y is equal to 1 of minus 1. So this is what? This is f of y given x is equal to minus 1 of 1 times probability of x is equal to minus 1 divided by fy of 1, right? This is fine. And we know y given x is equal to minus 1 follows the normal minus 1 2 distribution. So we can just solve for this. It's the same process that we followed for the other two. Hope this is clear.
Yes, ma'am. I got it for the first option only. I have doubt, ma'am.
Okay. I might will have to close the session. It's like power cut and it's raining heavily here. Uh, so if you have more doubts from week 5, so we have tomorrow also one session, and then Sunday also we have session scheduled. So we'll discuss it over there.
Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you all. Yeah.
Good night, ma'am.
Good night.
Thank you, ma'am.